Two chords AB and CD of lengths 5 cm and 11 cm respectively of a circle are parallel to each other and are on the opposite sides of its center. So let us take a circle and it is having its center O. We are drawing AB of 5 cm and CD of 11 cm on either side of its center in such a way that both are parallel to each other. If the distance between AB and CD is 6 cm, find the radius of the circle. So we know distance means the length between two lines. So between AB and CD, if we draw a perpendicular EF, it will be of the length 6 cm. And since we know about perpendiculars and circles which are passing through centers, so we will assume that EF is in such a way that it is passing through the center of the circle O. We need to find the radius of the circle. So radius means what? Any point on the circumference and the center being joined. So OB, OA, OC and OD, anything if we find, that will be the radius of the circle. Welcome to Math-o-tropism. Understanding what is given and identifying the concept. Given are two chords AB and CD of a circle parallel to each other, with AB and CD being 5 cm and 11 cm respectively. We have drawn the perpendicular EF passing through the center, and given is EF is equal to 6 cm. Now since this is perpendicular, angle OEB is equal to angle OEA, which will be equal to OFD, which will be equal to OFC. All are 90 degrees since it is the perpendicular distance between the two lines. We need to find the radius R, that is OA, OB, OC or OD. So we will first assume we will join only OB and OD. Then we can see that we are forming two right-angled triangles OEB and OFD. Now let us take that OE is x centimeter. Now if OE is x, then the total length EF minus of OE will give me OF, which is nothing but total is 6 minus of this x. So my OF is 6 minus x centimeter. We need this because we have two right-angle triangles and we will be needing OF and OE. That's why I am taking the lengths. Now to find the radius, I know I need to find OB and OD, and we can find this by equating the two right-angled triangles because both their hypotenuse are r centimeter. So I will take these two triangles one by one. Now first we need to know what is EB and FD. We know one side is the hypotenuse, which is r, and the other side we just now found as x and 6 minus x. So we need to find the balance bases EB and FD. So when we see the perpendicular and the circle, we remember a theorem that perpendicular from the center to a chord bisects the chord. So it means now OE is bisecting my AB and OF is bisecting CD. So as a result, we have that EA will be equal to EB, which will be equal to 5 by 2 centimeter, and similarly FC is equal to FD, which is equal to 11 by 2 centimeter. So keeping this in mind, we now have two right-angled triangles OEB and OFB with all its sides given in the figures. So first we will be taking the first triangle OEB. So OEB by Pythagoras theorem is OE square is plus of EB square is equal to OB square. So which means 5 by 2 the whole square plus x square is equal to r square. Similarly with the other right angled triangle OFD, we have OF square plus FD square is equal to OD square. So 11 by 2 the whole square plus x square is equal to r square. So from 5 and 6 we can see that both the right hand sides are r square. So we can equate the two equations to get x, and then we can substitute in one equation to get r. This is how we are going to proceed. So forming equations and solving the sum. Given are two chords parallel and on the opposite sides of a circle. AB is 5, CD is 11 centimeter. Construction is we are going to draw EF perpendicular to AB and CD. So EF is 6 centimeter. So as a result OE is equal to X centimeter and OF is equal to 6 minus X centimeter, and all the angles OEB is equal to OEA is equal to angle OFD is equal to angle OFC will be 90 degree. We need to find the radius OD, which is equal to OB, which is equal to R centimeter. So first we will consider the chords CD and AB. Now OE is perpendicular to AB and OF is perpendicular to CD. So as a result AE is equal to EB, which is equal to AB by 2, because we have the perpendicular from the center of the circle bisects the chord. Similarly, CF is equal to FD, which will be equal to half of CD, which is 11 by 2 centimeter. Let us keep this as equation 1. Now let us take the right angled triangle OEB. So OE square plus EB square is equal to OB square. So this comes as x square plus 5 by 2 the whole square is equal to r square. When we are substituting from equation 1, let us keep this equation as number 2. So taking the triangle OFD, again it is a right angle triangle, so we can apply the Pythagoras theorem. So OF square plus FD square is equal to OD square, which means 11 by 2 the whole square plus 6 minus x the whole square is equal to r square. Let us keep this as equation 3. Now equating 2 and 3, we get both are r square on the right hand side, so we can equate the left hand side. So 5 by 2 the whole square plus x square is equal to 11 by 2 the whole square plus 6 minus x the whole square. So x square minus 6 minus x square is equal to 11 by 2 the whole square minus 5 by 2 the whole square. We have rearranged the terms with x terms on one side and the constant terms on the other side. We can see that both have the formula a square minus b square. So we will be just using a square minus b square is equal to a plus b into a minus b. As a result, if a is x and b is 6 minus x, we get x plus 6 minus x into x minus 6 minus of x is equal to 11 by 2 plus 5 by 2 into 11 by 2 minus 5 by 2. When we simplify, this will become as 6 into 2x minus 6 is equal to 16 by 2 into 6 by 2. So as a result, 6 into 2x minus 6 is equal to 8 into 3, which gives us 2x minus 6 is 8 into 3 by 6, which when simplified is to give 4. So 2x minus 6 is equal to 4, and that is 2x is equal to 10, which implies x is equal to 10 by 2, which is 5 centimeter. Now since we got x, we will substitute in equation 2 to get 5 by 2 the whole square plus 5 square is equal to r square, which means 25 by 4 plus 25 is equal to r square. When we take the LCM, it comes as 25 plus 100 by 4, which is 125 by 4. So r square is 125 by 4. Taking square root on both sides, we have r is equal to root of 125 by 4. When we split it into the prime factors, we have root of 5 into 5 into 5 by 2 into 2. Taking the pass, we get 1 5 outside the root and 1 2 outside the 2 in the denominator, and remaining 5 will be in the root. So we get it as 5 into root 5 by 2 centimeter. So as a result, the radius of the circle is 5 root 5 by 2 centimeter. Hope you understood and found it easy. Thank you.